A hospital in England closed an entire ward, not because of a virus, not because of bacteria, because of a fungus. They tore out the flooring, they replaced the equipment, they deep cleaned everything, and then they checked the ceiling tiles. The fungus was inside the ventilation system. It had spread through the air of the entire ward, silently, invisibly, while patients were sleeping in their beds. That fungus has a name, Candida auris, and right now it is inside hospitals in 40 countries around the world, waiting. Here is what nobody is telling you loudly enough. This fungus appeared out of nowhere. 2009, Japan. A doctor swabbed the ear of a patient. What grew in the lab had never been documented in the entire history of medicine. A completely new fungal species. They named it Candida auris. Auris, Latin for ear, it seemed small, isolated, probably nothing. But something was different about this one. Something that would take years to fully understand. And by the time the medical community understood it, it was already everywhere. In 2016, doctors found it in America for the first time. 51 patients. Just 51. They thought it was contained. They thought it was manageable. They were wrong. By 2023, there were 4,514 cases. By 2024, there were over 6,000. In one country. In 1 year. That is not a slow creep. That is an explosion. And those are only the confirmed cases. Only the hospitals that knew to look. Only the patients specifically tested. How many more went undetected? How many hospitals never tested at all? Nobody knows. And that unknown number is the scariest number of all. Now let us talk about what makes this fungus unlike anything medicine has faced before. Because this is where it gets truly dark. Doctors treat fungal infections with antifungal drugs. There are three main classes: azoles, polyenes, echinocandins. Think of them as three shields standing between a patient and death. Candida auris has already broken through two of them. Over 95% of all strains are fully resistant to azoles. Gone. Useless. Around 15% are resistant to polyenes. Increasingly useless. The third shield, echinocandins, is the last line of defense, and resistance to that is rising. Some strains of Candida auris are resistant to all three. Every antifungal drug available to modern medicine. Nothing works. Doctors call these strains pan-resistant. Pan-resistant means you are standing in a hospital in 2026 with every medical tool humanity has ever developed, and you have nothing left. You are fighting a fungus with empty hands. Now let me tell you about a real person, a 72-year-old man. Routine hip replacement surgery at a large city hospital. Everything goes as planned. He wakes up. The surgery is successful. 3 days later, he develops a fever. The medical team investigates. Blood cultures come back. Candida auris in his bloodstream. He did not bring it in from outside. He picked it up inside the hospital itself. From a surface, from equipment, from another patient who had been carrying it without knowing. The doctors start antifungal treatment immediately. The strain is resistant. They switch medications. Resistant to that too. They escalate to the last available option. His immune system, weakened from surgery, cannot keep up. He dies 6 weeks after routine hip replacement. Not from the surgery, from a fungus that was living in the walls of the hospital before he ever walked through the door. That story is not unusual. That story is happening in hospitals right now. In the United States, in the UK, in India, in Australia, across 39 states, across 40 countries. And in most cases, the patients who die from Candida auris went in for something else entirely. Something routine, something survivable. And the fungus was already there, waiting for them. Now here is the question that stumped scientists for years. Where did it come from? Because the origin story of Candida auris is one of the strangest in the history of modern medicine. When researchers analyzed the earliest strains from different continents, they found something that broke every rule of pathogen emergence. The strains were genetically distinct from each other, not related, not descended from one source. They had emerged independently on 4 different continents at roughly the same time. South Asia, East Asia, South Africa, South America, 4 separate emergence events simultaneously. That essentially never happens. Pathogens spread from a single origin. They travel, they evolve. They do not spontaneously appear on 4 continents at once, unless something changed globally at the same time, and that is exactly what happened. The temperature of the planet changed. Here's the theory now gaining serious scientific traction, and it should disturb you. Fungi generally cannot infect warm-blooded animals. Our body temperature is the barrier, too hot for most fungi to survive inside us. But as global temperatures have risen over recent decades, something shifted. Certain fungi began adapting to warmer environments. Not intentionally, not dramatically, just slowly, generation by generation, tolerating slightly higher temperatures, then slightly higher again. And at some point, Candida auris crossed the threshold. It learned to survive at human body temperature, and then it learned to thrive there. It happened on 4 continents simultaneously because the temperature change was global. The fungi adapting to it were everywhere at once. If that theory is correct, and the evidence is increasingly pointing in that direction, climate change did not just raise sea levels. It did not just cause wildfires and floods. It helped create a new human pathogen, one specifically evolved to live inside us. A fungus shaped by a warming planet, designed by accident for us. Let us go back to the hospital ward, back to the ventilation system, back to the ceiling tiles, because that story is not one isolated case. It is a pattern. Candida auris forms biofilms, microscopic fortress structures on surfaces, on equipment, on catheters, on implants. Inside those biofilms, the fungus is essentially untouchable. Standard hospital disinfectants cannot penetrate them. Even the antifungal drugs that work against free-floating Candida auris cannot reach what is protected inside a biofilm. It becomes invisible to both cleaning and treatment at the same time. And then it sheds, releasing cells into the air, onto surfaces, onto the hands of healthcare workers, into ventilation systems, through ceiling tiles, across entire wards. In one documented case, a hospital found Candida auris on a floor that had not housed a confirmed patient for over a month. The fungus had outlasted the patients. It owned the ward. And it travels without being seen. Because here is the detail that turns a hospital problem into a global problem. Candida auris colonizes patients without making them sick. The fungus lives on the skin, in the gut, in the airways. No symptoms, no illness, no warning signs. The patient feels completely fine, but they are carrying Candida auris and shedding it onto every surface they touch, into every room they enter. A colonized patient transferred to another hospital brings it to a new facility. A colonized patient discharged to a care home carries it into a new environment. Healthcare workers carry it between patients without knowing. No symptoms, no signs, nothing to stop it. This is how Candida auris reached 40 countries without a single dramatic outbreak moment. No explosion, no emergency declaration, just quiet, invisible, unstoppable movement through the healthcare systems of the entire world. So I want to ask you something. Are the people responsible for keeping hospitals safe actually ready for this? A specialist in infectious disease at Yale School of Medicine was asked exactly that question. Are hospitals prepared for larger Candida auris outbreaks? His answer was one word: probably not. Probably not. Not from a pessimist, not from a conspiracy theorist, from a Yale infectious disease specialist, talking about what is already happening inside hospitals right now. Probably not. So, what is actually being done? Some new antifungal drug classes are in development. Early results from a class called orotamides are cautiously promising. But drug development takes years, sometimes decades. And Candida auris has already shown it can develop resistance to a drug during a single course of treatment. While the patient is still being treated, the fungus adapts in real time against the thing trying to kill it. Mid-treatment, the CDC classifies Candida auris at their highest possible threat level. Urgent, not serious, not concerning. Urgent and still. Most people have never heard of it. Here is the comparison that lands hardest. MRSA, the antibiotic-resistant superbug that became a household name. Featured in documentaries, covered in news cycles for decades, feared worldwide. Candida auris is more drug-resistant than MRSA. It survives in hospital environments longer than MRSA. It is harder to detect than MRSA. It kills at a comparable or higher rate than MRSA. And MRSA took 20 years of global awareness campaigns, infection control overhauls, and billions in research funding to bring under any kind of control. We are at the very beginning of that journey with Candida auris. Except this time, the fungus is already in 40 countries, already resistant to most of what we have, already inside the ventilation systems, already in the ceiling tiles. And the clock started in 2009. We are 16 years behind. Here is what I want to leave you with. The next time someone you love goes into a hospital, a routine procedure, a planned surgery, a recovery stay, Candida auris is present in healthcare facilities across 39 U.S. states and 40 countries worldwide. It is on surfaces, on equipment, on the skin of other patients who feel completely fine. It causes no symptoms until it is already in the bloodstream. And when it reaches someone whose immune system cannot fight back, the tools available to their doctors are running out. Resistant, pan-resistant, untreatable. We built the perfect conditions for this fungus. Overcrowded hospitals, decades of antifungal overuse, a warming planet. We opened the door without knowing it. And Candida auris walked through, made itself at home, and it has been spreading through the walls ever since. The most dangerous things in the world right now are not always the ones making the loudest noise. Sometimes they are the ones growing in silence, in the walls of the buildings designed to heal us, in a ventilation system, in a ceiling tile, in a patient who feels perfectly fine. Is the world paying enough attention to what is already inside our hospitals, or are we going to find out the hard way? Again, drop your answer in the comments below. And if this video made you think twice about something you thought was safe, there is one small thing you can do. Hit subscribe, because every week on Sick Nature, we go deeper into the things that live, spread, and evolve in the shadows of nature. Viruses, fungi, parasites, the hidden world most people never see. You found this channel for a reason. Do not miss what comes next.